Good morning. Today we are finding special products of polynomials. Polynomial, again, means many terms. So it says find the product. Product means multiply. So first, going back to what we learned in Chapter 8, whatever is written in parentheses, we need to write this many times. Now, you can't just put the 2 to the 4, the x, and the y because of this minus sign right here. If there wasn't a minus sign, if it was all multiplied, then you could just distribute the exponent, but you can't because of that exponent of 2. We need to write whatever's in here 2 times. So I have 4x minus y multiplied by 4x minus y. So we learned the other day, if we have a binomial, meaning 2 terms, multiplied by a binomial, also 2 terms, we can draw a box to help us multiply. We talked about this as making a smoothie. We have these ingredients, 4x minus y, and we're going to combine them with these ingredients, 4x minus y, to see what smoothies we're going to make. So this is, remember, just really a negative 1y, and this is also a negative 1y. So when I multiply, 4 times 4 gives me 16. X times x, there's 2 x's here, so that makes x squared. Remember, x plus x is 2x. But x times x is x squared. So we're multiplying, it's x squared because these are touching multiply. And then 4 times negative 1 is negative 4. There's an x here, and there's a y. So xy, we made a smoothie, that's xy. Here, negative 1 times 4, again, multiplies just make negative 4. These ingredients, apples and oranges, we have an x, and we have a y. They're all together now in that new term, negative 4xy. Then last, negative 1 times negative 1 makes a positive 1. And then y times y is 2y's, or y squared. So if you wanted to write this all out, you could. We could write 16x squared minus 4xy minus another 4xy plus 1y squared. However, if you notice that both of these two terms have an xy, we could have combined these together right away. A negative 4xy and another negative 4xy. Negative 4 and negative 4 make a total of negative 8xy. So I have 16x squared minus 8xy plus 1y squared. So this is our final answer. This is our polynomial that we were looking for. We have all of our x's, our xy's, and our y's. We combined our xy's together. Alright, let's try the same thing over here. Reminder that whatever we see in parentheses, we need to write this many times, 2 times. So I'm going to write 3x plus 4, and we're going to multiply it by 3x plus 4, 2 times. I wrote it. So if I have 2 terms by 2 terms, I'm going to make a box to multiply. We'll think of these as our smoothie bins. We have these ingredients, 3x plus 4, multiplied or combined with these ingredients. We need to multiply them out. 3 times 3 gives us 9. X times x is x to the power of 2. 3 times 4 is 12. We can put a plus there. And then there's just an x. 3 times 4 again is 12 with an x. And 4 times 4 is 16. So if we write from our highest degree to the lowest, this has the highest exponent, 9x squared. Then I have a 12x and another 12x. 12 plus 12 is 24x, and then last, plus 16. So these are our 3 terms, our trinomial, that we ended up with. Let's go on to slide 2. Same thing, we're practicing this multiple times so we become experts at it today. We have 3m plus n, 2 times. 3m plus n. So if we multiply this out, 3m plus n on one side and the same on the other, because it's really the same thing 2 times. 3 times 3 gives us 9. M times m is m to the power of 2. There's 2 m's there. 3 times 1 is 3. And then in alphabetical order we have an m and an n. And then over here, same thing. 3 times 1 is 3. M first, and then n. And then 1 times 1 is still just 1. n times n, there's two n's, or n to the power of 2. So if we go from our highest degree to the lowest, 9m squared, we have a 3mn and another 3mn, so we can combine those together. We have a total of 6mn's. We combine those. And then last we have plus 1n squared. So this is our final answer right here in alphabetical order: m's, then mn's, and then n's. Alright, I would like for you to try this one on your own. Write it 2 times and then multiply it out. So I'm multiplying this out. Here's my box I'm going to use. I'm going to use my cheat straight line method here. So I have 5x minus, oopsies, the minus goes with the 2. 5x minus 2y, and same thing here, 5x minus 2y. So 5 times 5 is 25. X times x is x to the power of 2. There's 2 x's there. 5 times negative 2 is negative 10. X and y, you just write it as x times y. Then same thing here, 5 times negative 2 is negative 10. There's an x first, alphabetical order, then a y. Then negative times a negative makes a positive 4, and then there's 2 y's, or y squared. So then we have here 25x squared. There's my x to the positive 2. And then I have here an xy here and an xy here. If they're both negative 10, a negative 10xy and another negative 10xy make a total of negative 20xy. And then plus 4y squared. And there's our answer. Alright, these ones are already written 2 times for you, so we just need to make our box to multiply. I'm going to draw boxes for both of these while I'm at it. Because we have a binomial by another binomial, or 2 by 2. I didn't draw the boxes for you on these because I need you to realize that if you have 2 terms here and 2 terms here, you're going to need a box that's 2 by 2. So it doesn't matter which one you put where. I'm going to put this one on the top, x minus 3y, and this one, x plus 3y. Notice the only difference is this was minus and this is plus. So 1x times 1x gives me still 1 times 1 is 1, but x times x is x to the power of 2. Then I have 1 times negative 3 is negative 3, but I have an x and a y. And then same thing here, 3 times 1 is 3, x and a y. And then last, 3 times negative 3 is negative 9, and there's 2 y's, or y squared. So if you happen to write this all out, we would write 1x squared minus 3xy plus 3xy minus 9y squared. I just wrote out all 4 terms. I went across and across. However, if you didn't want to do that, if you wanted to combine your like terms as you go, you would have combined these 3 xy's because they both have the same letters, xy, xy. But a negative 3 and a positive 3 cancel out and make 0. So we don't need to write any of that. We just have 1x squared minus, this is a minus here, can't really see that, minus 9y squared. The minus came from right here. So we kind of eliminated our middle term. That's why we are calling these ones special products, because something happened. The middle term's eliminated. So if we have the same thing here, 2x plus 1, and here 2x minus 1, what do you think is going to happen? Let's find out. 2 times 2 is 4. X times x is x squared. Then 2 times 1 is 2, and there's just an x. Again, 2 times 1 is now 2, but it's a negative 2, and there's an x. Then negative 1 times 1 is negative. 1 times 1 is just 1. So you could write all the terms out separately. I'm going to start with just our highest exponent, 4x squared. What happens when you have a negative 2x and a positive 2x? Well, they're going to cancel out. Positive 2 and negative 2 makes 0. So we have nothing there, and then just minus 1 left over from right here. Alright, let's keep going. 2 more just like this, just to get our practice in with multiplying or finding the product. So first, it doesn't matter which term you write where. I could write 3x plus y here, and 3x minus y here. It does not matter. We do, however, need to multiply always. 3 times 3 is 9. X times x is x to the power of 2. Then over here again, this is a negative 1, so 3 times negative 1 is negative 3. There's an x and a y. Then same thing here, 3 times 1 is 3. There's an x up there and a y over here. So notice something's going to happen with those two terms. 1 times negative 1 is negative 1, and y times y is y to the power of 2. There's 2 y's. So write your highest degree, highest term first, 9x squared. Our 3xy and our negative 3xy, this is a negative here, cancel out, they make 0. 3 minus 3 is nothing. It's like 3 apples and 3 apples here that you're going to throw away. That makes nothing. Then we have negative 1 y squared. Alright, last one like this, I believe. If I have t minus 5 on one side and t plus 5 on the other, I hope you can predict what's going to happen with our middle two terms. If it's the same but one's positive and one's negative, now that we've done a couple like this. T times t is just t to the power of 2. There's 2 t's there. T times negative 5, that's really negative 1, so we have negative 1, not negative 1. I am losing my mind. For some reason I thought this was the letter. It's a 5. Negative 5 times t is just negative 5t, because that's really a 1t. 5 times t is just 5t, just put them together, because it's really a 1t. And then 5 times negative 5 is negative 25. So starting with our highest degree, we have t squared. Combining our like terms, because these ones are both just t's, 5 minus 5 is 0, those cancel out, and then we just have minus 25. So that's our answer. Next, we have what's called a Punnett square. This is something new. Maybe you've heard about these in science. It says the color of the dark patches of a border collie's coat, or their fur, is determined by a combination of 2 genes. An offspring, or a baby or a child, inherits or gains 1 patch of color gene from each parent. Each parent has 2 color genes. And the offspring has an equal chance of inheriting either one, so a 50-50 chance. So basically, to get the dark patch, they inherit 1 gene from each parent. The B represents the dominant trait. Anytime you have a capital letter, that's going to be the dominant trait. Meaning that if one of the parents has that dominant trait, if you multiply it and it still is in that square, that's going to be what's dominant or what's going to show on the dog. If you get the lowercase, like the letter R, here's B and here's R, that's what's called a recessive gene, R-E-C-E-S-S-I-V-E, recessive gene, which means it's not going to show. You have the gene, but it's not going to show up. For example, in humans, a hitchhiker's thumb is a thumb that points backwards when you point your thumbs up. Sometimes people don't have a hitchhiker thumb and your thumb points straight up. Those are what are called dominant recessive genes. One in your parent, if one of your parents has it, will take over and kind of hide the other gene and show. I'll give some examples of that in class as well. So, what percent of the possible gene combinations of the offspring result in red patches? So, I can assume, based on these letters, it doesn't say here, that B represents brown and R represents red. normally they'll tell you what each letter means. Okay? So if this person is getting 1b from here, and this person is also getting 1b from here, in a Punnett square we write them next to each other instead of writing b squared. We write b, b, just next to each other. This one, dominant, or the capital letter, always comes first. We have a b and an r. And here, down here, we have one big B and one little r. And down here, we just have two little r's. So what percent of the possible gene combinations of the offspring result in red patches? So meaning there are two r's. Well, this is only 1 out of 4 squares, because this is going to be brown. This, the capital letter, is dominant, so even though it has the gene for the red, it's not going to show up, and this one is going to also have brown patches. This one also has a capital B. It's dominant, so it's going to have brown patches. And this one is going to end up with red patches. So what percent? Well, if the whole graph right here was 100%, 1/4 of it, some of you know if you talk about one whole dollar, a fourth of a dollar would be 25 cents or 25%. Or just think 1 out of 4 as a percent is, or as a decimal, is 0.25, which is also 25%. So it says show how you could use a polynomial to show the possible gene combinations of the offspring. If you wanted to, instead of writing BB, you could write B squared. Then there's a BR here and a BR here. We could write that as 2BR. And then plus R to the power of 2, or R squared. This is how you would write it as a polynomial, but normally in a Punnett square we write them next to each other. Alright, these last few questions are exactly the same as some we've already done. They just look a little bit different. So it says perform the indicated operation using the functions f of x equals 3x plus 0.5 and g of x is 3x minus 0.5. So here in parentheses I have f of x. Well, what is f of x? I'm going to take this out and I'm going to really plug in this piece. It says 3x plus 0.5 squared. So the squared tells me I need to write this 2 times. So I have 3x plus 0.5, 3x plus 0.5. I wrote it 2 times. Now that I see I have 2 terms by 2 terms, I'm going to make a rectangle or a box to multiply. So I have 3x plus 0.5 times 3x plus 0.5. So let's multiply. 3 times 3 is 9. X times x is x squared. Then I have 3 times 0.5. That's one that I would probably plug in my calculator. 3 times 0.5, or half of 3, would give me 1.5, and there's an x. 3 times 0.5 again is same thing, 1.5, and there's an x. 0.5 times 0.5, if you plug that in your calculator, will give you 0.25. A half times a half is a fourth. So we can combine our like terms, our smoothies that are the same. Remember when we made smoothies, we multiplied, made something new. I'm going to write first my highest exponent, 9x squared. 1.5 plus 1.5 is going to give me 3x, and then plus 0.25. So that is my answer. Now we have f of x, which is really, over here it says 3x plus 0.5, and we're going to multiply it by f of x, g of x, which is 3x minus 0.5. So the only difference is this one's plus and this one is minus. So this is already written out for us. We just need to simply multiply, or draw our box, so we can distribute, multiply here. So I have 3x plus 0.5, and I also have 3x minus 0.5. So 3 times 3 is 9. X times x gives me 2x's, or x squared. 3 times 0.5, we said earlier, 3 times 0.5 was 1.5, 1.5x. 3 times negative 0.5, same thing, that's just a negative 1.5x. There's the x up there. And then I know these are going to make a negative. 0.5 times 0.5, we plugged in our calculator earlier, gives me 0.25. So I have 9x squared. Be careful here, a negative 1.5 and a positive 1.5 eliminate to make 0, and then I just have minus 0.25. And then last, in my parentheses here, I have g of x right here, which is 3x minus 0.5, but I have it 2 times. So I'm going to write this out 2 times, just like it says. Exponent is 2. 3x minus 0.5, 3x minus 0.5. So we're multiplying, so I'm going to draw my box 2 by 2. I know it's 2 by 2 because it's 2 terms here and 2 terms here. Same thing on both sides, and then multiply. 3 times 3 is 9, x times x is x squared. 3 times 0.5, we've done this many times, now it's a negative 1.5x. Same thing here, negative 1.5x. And then 2 negatives, be careful here, make a positive. 0.5 times 0.5, just like over here, made 0.25. And then we simply need to write out our answer. I have 9x squared. A negative 1.5 combined with another negative 1.5 makes a total of negative 3x. And then plus 0.25. Or 1/4. Alright, a lot of what we've done today is very similar. We have one question left, also similar to our Punnett square. It's about basketball statistics. It says you are on the basketball team and you want to figure out some statistics about foul shots. The area model, that's what this is called, the area model, showing area like base times height, shows the possible outcomes of 2 attempted foul shots. So before we start, C stands for complete. I stands for incomplete. So they want to know what % of the 2 possible outcomes of 2 attempted foul shots result in you making at least one of the 2. Explain how you found your answer using the table. So if we have 2 foul shots, and you could get complete or incomplete on any given one. Let's say we both get 2 completes. We could say 2 completes. CC. You could write that as C squared, but normally we don't write it like that when it comes to a Punnett square. Then over here we have 1 complete and 1 incomplete. This is an I. Then over here we have 1 complete and 1 incomplete. Notice I wrote them both in alphabetical order, C and then I, C and then I. And then at the end we have incomplete and incomplete. So these are all the possible outcomes you could get. So what % of the 2 possible outcomes of the 2 foul shots results or happens or makes you get at least 1 foul shot, 1 foul shot complete. You make it in the basket. So at least 1, well this has at least 1, this has at least 1 complete, and this has at least 1 complete. So that is 3 out of 4 total, but it asks for that as a %. 3 out of 4 is equal to 0.75 or 75%. It says, show how you could use a polynomial to model the possible results. Well, like I said, normally we write this as C squared. This is a 1 CI here and a 1 CI here, so that would be 2 CIs, or complete, incomplete. And then plus we also have II, or I squared. So this is written as a polynomial. Normally Punnett squares are written just letters next to each other, but because they asked for it as a polynomial, we're going to list it like that. Alright, that is it. Your homework is here in front of you. You can skip 19, 20, and 21. Otherwise, you have to do the whole thing. Good luck!